Okay, a cylindrical glass rod in air has refractive index of 1.52. One end is ground to a hemispherical surface with radius 2 cm as shown in figure. Find the position of image for a small object O, okay, 8 cm to the left of the pole. Okay, so now we want to find the position of image. Okay, position the image distance, okay, which is V. Yeah, we need to find V. So here we have this is a refraction at one surface. Yeah, refraction at spherical surface. Refraction at one surface. Okay. First I write down the formula. We have this formula: n1 over u plus n2 over v equal to n2 minus n1 over r. We're going to use this formula. So n1 over u plus n2 over v equal to n2 minus n1. Yeah, n2 minus n1. N2 minus n1 over r. R is the radius of the spherical surface. Yeah, radius. Okay, so here it given us the 1.52. This is the refractive index of the glass. Refractive index of glass. So okay, write down over here. Refractive index of glass is 1.52. Okay, that's for glass. And then it has radius 2 cm. So write down also radius. Okay, so where is the radius? Here you see this is the center curvature. Center curvature of this spherical surface. So radius should be distance to the center curvature. This is the r. Okay, this is the r. Radius, the distance of spherical surface to the center of curvature. Center curvature is the radius of curvature. Okay, 2 cm. And then find position of image for object. This is 8 cm to the left of the pole. Pole is the P. Yeah, P. So 8 cm is the object distance. Yeah, object distance to the left of the pole. So distance from pole to the object is the object distance. Okay, we can write that down also. That is the object distance, U. Yeah, U, which is 8 cm. Okay, 8 cm. Okay, so just now the R here is 2 cm. Right down also over here 2 cm. Okay, so now I want to find image distance. Okay, good. So I'm going to use this formula. We have n1 and n2. Which one is n1 and n2? But we only have the refractive index of glass, n for glass. So why we have two refractive index? So remember, okay, this formula. We need to draw incident ray and refracted ray. So but the graph already provide you, the diagram already provide you the incident ray and refracted ray. So it's easy. Okay, so write down. Okay, which one is incident ray? Incident ray is from the object. Okay, from this is the object. So incident, so the ray coming out from the object is the incident ray. Yeah, incident ray. And then okay, remember refraction, the light can pass through. The light can pass through. Refraction, the light can pass through. It's not mirror. If mirror, the light is reflected, cannot pass through. Yeah, the reflected ray will be in same position with the incident ray. But for refraction, the light can pass through, so the light has go to the other side. Yeah, enter the glass. Go to the other side. So this is the refracted ray. Refracted ray has go to the other side, the opposite side of the incident ray. This is the refracted light. Yeah, reflected light. Refracted light. Okay. So now, where is n1? Where is n2? So n1 is where the incident ray. Yeah. So incident ray is in the air, yeah, from air. The light go from air into glass. Go from air into glass. So from air, the incident ray is in the air. So here is N1. So here should be N1. Okay. So you see the light come from the air into glass. So the air is the N1, and then glass is the N2. Glass is the N2. So the glass provided the refractive index 1.52. So N2 should be 1.52. Understand? 1.52. So incident ray is in the air. So air is refractive index 1. Understand? So refract N1 is where the incident ray. N2 is where the refracted ray. Okay, N1 is where the incident ray. N2 is where the refracted ray. That's why we need to draw the incident ray and refracted ray first. Then only we will know where is N1 and N2. Okay, so if the light come from, okay, what I can say is outside is the air, inside is the glass. So if the light come from the air to the glass, so air is the N1, glass is the N2. But if let's say the object is inside the glass, okay, if let's say I give another example, if let's say right now let's say my object is over here, then if the incident ray is going from, inside is the glass and then go to the air. If this case, light can pass through. So the light coming from the object is the incident ray, and then the light go to the other side because of refraction. Okay, remember this is the glass. Okay, this is the glass. Okay, all right. So the light come from the object and go to the air. Okay, this is the refracted ray. And this is the refracted ray. So now, which one is N1? So for this case, N1 will be over here. N1 will be this one, 1.52, the glass. Understand? This one will be N1, and then the N for refracted ray, okay, is N2. So this one will be N2. Understand? So if the light come from the glass to the air, then the glass will be N1 and air will be N2. Okay, so if the light come from the air into glass, then the air will be N1, glass will be N2. Understand? Light come from air to the glass, so this is N1, N2. If the light come from glass to the air, so glass is N1, air will be N2. Understand? So N1 is always with incident ray, N2 will be always with refracted ray. N1 will always be with the incident ray, N2 always with the refracted ray. Okay, so you need to see the light come from where to where. That's all to determine N1 and N2. Okay, N1, N2. And then this one is N2, N1. Okay. All right. Coming back to here, so we already know which one is N1, N2. So N1 is where the incident ray. Oops. N2 is where the refracted ray. Okay. So now, okay. So we have the object distance also. Okay. So U should be positive or negative. So remember, of this one, U always compare with incident ray, and then V and R compare with refracted ray. Understand? If same side positive, opposite side negative. Okay, I want to write it down here. Compare. Yeah, the object always compare with incident ray. Okay, and then V and radius compare with refracted ray. So if same side, it is a positive real object. If opposite side, it is negative or virtual image. Understand? So this one I want to put in brackets. All right, we will reuse this one. So or you can simplify everything in this one. Yeah, I see that. You always compare with incident ray. The rest like image, focal length, radius, curvature, always compare with refracted ray or reflected ray. This is a comparison partner. Only the object distance compare with incident. The rest all compare with reflected ray. Same side is positive, opposite side is negative. Okay, positive is where the light is. So, okay. So first we look at the object distance. This object distance compare with incident ray. So object compare with incident ray. Is it same side? Is the object distance same side with incident ray? Same side. So this one should be U positive. This one should be U positive. Positive 8 centimeter. And then how about the V? We need to find V. We don't know yet. But we have the radius. Radius compare with who? Radius compare with refracted ray. Yeah. Radius compare with refracted ray. Is it same side? Is the radius same side with refracted ray? Okay. So look at this surface. The radius is over here. So this radius is same side as the refracted ray. Yeah, same side. See that? Same side. So same side is positive. So this radius should be positive. So we can say this radius is positive. Why this radius is positive? Because it is same side as refracted ray. Same side. So this is positive 2 centimeter. Okay. So now, okay, we have everything ready. We can substitute into the formula. So N1 is 1. Okay, N1 is 1. And then N2 is 1.52. 1.52. And then N2 minus N1. So it's 1.52 minus 1. Okay. Now U is 8 centimeter, which is positive 8 centimeter. Okay. So this is not SI unit. You must write down SI unit in the no. This is not SI unit, so you must write down the unit into the substitution. Okay, because we don't want you to make mistake. Assume it as meter. Yeah. If you don't write anything, we assume it is meter. So if not SI unit, you must write the unit together with the value. Yeah, when you substitute the value. Understand? In this case, we will not make mistake. Okay, we will also check if we don't write the unit together when you substitute the value, then you minus mark. Yeah, we will minus mark. Okay, if non-SI unit, you must put the non-SI unit together with the value when you substitute the value. Yeah, don't just put the value. Okay, so V, and then R is positive 2 centimeter. Positive 2 centimeter because this is radius is positive because same side as refracted ray. Because it's same side is positive. Understand? Radius compare with refracted ray, and then image also compare with refracted ray later on. Yeah. So okay, first of all, let's get the image distance. Okay, let's calculate and see what do we get. 1.52 over V. And then calculate that one, go to the other side. So 1.52 minus 1 equal to this one, and then divide by 2 centimeter, and minus 1 over 8 centimeter. Okay, so here we get 27 over 200, and then what is V? Let's calculate the V. And then 1 divided by answer 1, invert it, take the reciprocal, and then multiply by 1.52. So we will get So we get the answer is positive. We get positive answer, positive 11.26 centimeter. Okay. So what is mean by positive value? Positive value means it is real image. So where is it from? We get V positive. We get V positive. So V positive means it's a real image. First of all, I can say if V positive means it is a real image. And then secondly, where is the image from? Where is the image from? We get V positive. We get V positive. Is it at the left hand side or right hand side? What do you think? Use your mind. Okay, V positive. So V compared to who? V compared to who? V compared to who? Compared with refracted ray, isn't it? So now we get V positive. We get V positive. V positive. So it should be same side. So V compared with refracted ray. So we compare with refracted ray, and now V is positive. V is positive means it is the image is same side as refracted ray. So it's same side as refracted ray. Understand? The image should be same side as the refracted ray. The refracted ray is over the right hand side. So the image should be same side as the refracted ray because we get V positive. We get V positive. So the image should be same side as the refracted ray. Same side as the refracted ray over here. Yeah. So the image should be formed over here, same side as the refracted ray because we get V positive. So we got here. It should be formed. Where is the image? Yeah. So we should say the image is formed over here. That's why you see here image. So we get image. So we got how do I write? This is the image distance. This is the image distance. This V is the V is positive. The V is positive. Okay. The V is positive. This positive 11.26 centimeter from the pole of the mirror, pole of the surface. V positive. This V positive because the image distance is same side as the refracted ray. So this is the real image. We can say this is a real image. Why is it real image? Because the light fall onto this point. That means if we put a screen, over here. We put a screen over here. It form a real image. The reflected light fall onto the screen. The light fall onto the screen, and then it form a real image onto the screen, and then we can see it. Yeah, we can see the image on the screen just like you know, the image on the theater, on the screen, on the movie. Yeah. So the reflected light fall onto the screen. The light there is a light reaching the screen, and it form a real image on the screen. Okay, over this position. Positive is where the light is. Understand? That's it. Okay. So there is light fall onto the screen, form a real image. Okay. So why I draw the image is inverted? Why the real image is inverted? Back to the acronym which I have learned. RIVU. Revu. Real image, if the object is upright. What I can say, if the object is upright, if the object is upright, then the real image is inverted. Okay, so real image always inverted. So that's why I say, if you got a real image is always talking about image. A real image is always inverted. Virtual image is always upright. virtual image is always upright. Okay, that's why I draw the image is inverted, because I found out it is real image. It is real image because V positive. Okay, real image always inverted, virtual image always upright. Okay, I think that's all for this question. I hope you understand everything. Yeah, bye bye. See you in the next video.